Right. Let me check it whether everything is working or not. That's fine. Okay. This first hour lecture, I will talk about general concept of the linear systems. Let us start now. Before what I will talk will be known to you. Nothing exists. Understand this point? Nothing exists. In this entire cosmos, what you see, what I see, they do not exist. I am writing it here. What I am writing? My handwriting is very poor, and here also writing becomes difficult. Nothing exists. What you see in this entire universe is an illusion. This particular statement, because this is India, I also, while in Auckland, I also give the same talk, same lecture. People in this country have been telling you for thousands and thousands of years that nothing exists. Everything is an illusion. But people in the Western world, they think that they are mad people sitting in Himalayas, they are beggars, and they are saying nothing exists. Right? The same thing was told by a Western people, exactly the same thing. Nothing exists. Everything is an illusion. Right? And people gave him Nobel Prize. Exactly same thing, right? Nothing exists. What you see is an illusion. We say we are useless. A Western people say they gave him a Nobel Prize. And what is that? E is equal to mc square. Einstein theory. Everything is energy, nothing is existing. E is equal to mc square. This equivalent is nothing exists. Everything is energy. Everything in this entire cosmos is energy, right? You are energy, I am energy, and I am telling you to understand classical control theory, unless you know Indian spirituality, your understanding on classical control theory is not zero but negative. You must understand what I am talking now, right? I have been telling in Auckland University for the last 25 years, right? Now the question is, if nothing exists, everything is energy, this particular pen looks different, you look different, he looks different, the table looks different, that whiteboard looks different, right? Why is that? It is because we are vibrating at different frequencies. Those things I will come later on, today itself. We are vibrating at different frequencies. So this is, in Indian spirituality can explain it. Nada Brahma, everything is sound, vibrating at different frequencies. We will come to that point in poles and zeros when I talk about. We are all vibrating at different frequencies, right? Everything is an illusion. You go to, this is the place, Goa, and you will find there are lots of seashores, people come to see the beach. You go and take the photographs. You go and take the photographs of the sea. And you show to your friends. You see, I have gone to Goa, very nice beach. See, the water color is beautiful, green. You say the water color is green. Then you say, water color is not green. He told, I have got the photographs. The photograph says it is green. You say it is not green. It appears to be green. Point be noted. It is not green, it appears to be green. If you go near the sea and take a handful of water and look into it, it has no color. So this is the reality. It is the distance between you and the reality that creates this illusion. Got my point? I'm giving another example before I proceed further. In the village, earlier days, no, not now, the cow herd people, they go to take the cows to the field to graze. There is a stick, and they will put a thread in the stick. And what they will do, you must have done it, many people have done it. You take a stick and put a thread, then rotate it. Now suppose this stick is one dimension, right? Once you rotate it, it appears as one dimension. You increase the speed of rotation, vibration frequency. You increase the speed of rotation, okay? This one will appear as a disk. It will appear as a disk. And not only that, the beauty is, it will not only appear as a disk, it will also behave as a disk. Because if you throw a small stone, it will deflect it from the top. Got my point? So who creates this thing? It is the vibration frequency. The frequency of vibration is giving an appearance of a single dimension to multi-dimension, right? So everything is energy. We all are vibrating at different frequencies, right? So nothing exists. Now if everything is energy, you see here. Now see this slide which I have taken here, this is the actual place where the Newton's law of gravity. Now see the modeling concept I am going to give in this course, this lecture. Apple falls. If you ask the people, apple falls, why apple falls? You will say, due to law of gravity. That is wrong. That is a mistake. Apple falls, full stop, no semicolon. Remember these things I am telling you, you are all academic stuffs. Apple falls, there should be a full stop, no semicolon. Before Newton, apple was falling or apple was going away? Before Newton, apple was falling or apple was flying upward? It was falling. Apple falls, that is the truth. It has nothing to do with the law of gravity. Newton told it is because of the law of gravity. After 1,000 years, somebody else will say it is not because of the law of gravity, it is because of some other reason, you will believe, right? But still, apple falls, phenomena has nothing to do with the model. Got a point? Phenomena is phenomena. Don't consider model with the phenomena. Phenomena cannot change, but the models can change. We'll see it. Models can change. Right? So apple falls is the truth. Law of gravity or not, that is questionable. That is questionable. And for your kind information, I'll tell you, the law of gravity was not found out by Newton alone. It was found by Aryabhatta and Brahmagupta years back by Indian scientists. What happened? All proof is there. Proof is there. Okay. So, model, so differential equation, transfer functions, all these things which you have studied and you are teaching now, they don't exist. You see, I am writing here this point, models do not exist. Models do not exist. The phenomena exist. Models do not exist. This point should be in the phenomena exist. The physical phenomena which occurs, that exists. Again, telling my handwriting is very poor, so please bear with my handwriting, right? Don't record the handwriting. Okay? Phenomena exists, right? So transfer function, I am coming to this point. If you ask the people, it does not exist. Okay? Differential equations doesn't exist. It is a model. It's a model of phenomena, right? One example which I give it here. Forget about those things. This is for you. Map is not the territory. Map is the model of the territory. Map is not the territory. Map is the model of the territory. Suppose I have got the India map. Suppose I have got the India map, and this is Delhi, and this is the parliament. Okay? And I will attack there, here. Will it happen? Will it happen? Because I am doing it here. Got a point? So map is the territory, it's not the model of the territory, it's not the territory. It has its own application, no doubt about that. But don't take the reality and the model of the reality to be same, right? See, this point I have put it in my book also. See here, this point, this slide I will go to. Everything in the cosmos is energy, and every object vibrates at certain frequencies. Energy is a fundamental aspect of the cosmos, and everything at its most fundamental level can be understood in terms of energy and vibrations. This idea is grounded both in physics and metaphysics. Matter and energy are interchangeable and are indeed interconnected. This perspective often draws from the Eastern philosophies. It is we people who have told it, right? I'm writing a book now, it's almost complete. It will be published by CRC Press, 900 pages in control systems engineering. I should have given by the time I left New Zealand. Only indexing is left. There I have put it. Okay? Everything is energy, and we are vibrating at different frequencies. Right? Now let us go a little bit deeper into that. Transfer functions do not exist. Because of all the academic stuff, I am not going to explain about the transfer function, all these things. You ask the students, what are the poles of a system? Poles and zeros. Have you heard this term? You must have teaching these things. Poles. And they will immediately say, you see, they will immediately say, the poles of a system where the transfer function becomes infinity. Do you understand this answer? By say s plus 5 into s plus 8 into s plus 15. You ask, not only 99%, 100% students will say, what are the poles of a system? When I go to the first control course, second control course, what are the poles of the system? The poles of the system where the transfer function becomes infinity. It's completely wrong. It's 100% wrong. First thing, transfer function do not exist. Differential equation do not exist. Okay? And I did not ask, I asked what the question. Understand the question very carefully. What are the poles of a system where the transfer function came into picture? When I am asking them, no question, what are the poles of a system? What is the transfer function? Transfer function is the model of the system, and model does not exist. It has no physical reality. So, understand this point. This cosmos is energy. We are all vibrating at different frequencies. Okay? Poles, there is little difference which I will also clarify, but just see, the poles are the natural frequencies of the system. I will explain these things. Not exactly true, I am telling exact truth, I will tell you later on. Just but have to understand this case. Poles are the natural frequencies of the system. Natural frequencies of the system. It has nothing to do. Poles are the natural frequencies of the system. That means we all vibrate. So naturally how we vibrate? What are the frequencies? I will explain these things to you. Tell me, at this particular point, Are you people vibrating at your natural frequency? Just let's answer. Are you vibrating at your natural frequency? Answer is no. You are not vibrating at your natural frequency at this moment. Because you are not interested to join the GIAN course. You have got other responsibility. Why should you come to the monsoon weather to Goa? Okay? But there is some compulsion. You want to enjoy with your reel or Facebook chat or Instagram. There is a person coming from outside and talking nonsense. So you are forcibly listening to me. You have been forced to a certain extent to listen to me, right? You are not vibrating at natural frequency. How you will vibrate? We all vibrate out of natural frequency in many places. This example I give it in the classroom, which is you can also give it to your students in the classroom. You go to the bathroom. Okay? You close the bathroom door and then switch on the hot water. Warm water is coming. You take bath. You see, there's many people, they are bathroom singers. Many people, they sing in the bathroom. Have you seen it? Bathroom singers. Okay? Natural frequency vibration. You are natural. Nobody is looking to you. Very nicely warm water is coming. You are free. You are relaxing. Relaxing tummy, technical term now. Now you vibrate at your natural frequency. Nothing, no pressure, nothing. Completely relaxed. Right? So, that is possible to know. You apply an impulse input and you give some signal measurement, you can measure the natural frequencies. So, poles are the natural frequencies or they are the characteristic modes. You see, the wordings I am using here, actually, they are the characteristic modes. Characteristic modes. I will explain clearly these things. Modes of a system. Actually, not the poles now, I am just correcting here. The eigenvalues of a system eigenvalues. I assume that you know control code a little bit. Eigenvalues are the characteristic modes of the system. Poles are the subset of that. We will give an example, it will be clear. Eigenvalues are the characteristic modes of the system. Let us understand from the very physical concept. Everyone, we all, human beings. Again, another concept I will give you. We are angry, we are compassionate. Okay, you are angry, you are compassionate. You are peaceful sometimes, peace-loving. Helping, let us assume, romantic. Okay, suppose these are the 2, 3, 4, 5. 5 characteristics. Suppose you have got 5 characteristics. We all have got around 5 to 10 characteristics, right? So these are our poles, the characteristic modes. The characteristic modes, the eigenvalues of us, right? And these are called the singularities. If you model us, these are called the singularities. Another concept I am giving, then I will relate everything here. Singularities. You understand the meaning of singularity of a function? How many of you, the academic staff, are teaching control codes? Just raise the hand. Just we are friends, don't refer. Anybody is teaching control codes? Anybody is teaching control to the, you are all academic staffs, no? Are you teaching control or signal processing? Which courses you are teaching? Okay, doesn't matter. Singularities. Suppose I will tell you, given up, you all people are here. I will tell you, tomorrow in Panji, there is a very nice restaurant. I will pay from my pocket and I will give you a treat. Come for dinner. Nice proposal or bad proposal? Nice proposal? tomorrow evening dinner time, we will give you a nice dinner in Taj Hotel in Panji, right? Very nice proposal. Even if it's a nice proposal, even if it's a very nice proposal, there will be some bloody singularities. Some people will object. Why Dr. Swai is telling to treat us in Taj Hotel? He must have some vested interest. You see, some people will object. Even if it's a good proposal out of 15, 20 students, people, 2, 3 people will be there, they will object. Now, this fellow is he must have some interest, vested interest. Therefore, he is doing these things. Why should you go? Huh? Anything, any good thing you do, always you will find some singularities, right? So, should I stop it? Because I know that anything I do, there will be some singularities, always. Okay, I always tell in the classroom there are bloody singularities, because they are useless people. I will certainly take you to the Taj Hotel tomorrow, even if 3 people object. But you must be a bit careful. What? Now suppose there are 3 people, 3 singular points. Suppose this person is a singular point, that gentleman in the other side is a singular point, and the man in that place singular point. So what I will do, I will call everybody and I will take you go to hell. You are singularity, you are objecting, you go. Right? But I must be very careful. Suppose those people who are objecting to my proposal, singularities, one is the son of the director, another is a relative of the Minister of Education, and another is known to the Prime Minister. Then I must be very careful. Those people who are objecting those bloody singularities, the strength is quite high. So I will do it, but I must know what is the strength. Who is objecting me? What is the strength? What are those called mathematically? Residues. Residues, strength of the singularities. Strength of the singularities. You understand the physical significance of that? These are the residues. We must calculate these are called the residues. In mathematics, what we call the residues, the strength of the singularities. We must be very careful. While analyzing, you should strength the singularities. The characteristic or the nature of the system depends not only of the poles or the characteristic modes, but the strength. Suppose we see here, there are 5 characteristic modes of this system: angry, compassionate, peace-loving, helping, romantic. Right? Each characteristic mode has got one strength: K1, K2, K3, K4, K5. They are the residues. Right? So if the residue corresponding to angry is very high, that person is very angry. Very angry. Right? If residue is very less, that particular mode is almost dormant. What am I? Because the response depends on like this. The response Ct is equal to K1 e to the power minus lambda 1t plus K2 e to the power minus lambda 2t plus up to Kn e to the power minus lambda nt. So this K1, K2, K3, it will decide how much is that characteristic is dominant. All characteristics are there. We have got all characteristics. But some people are, say, angry people, some people are romantic people, some people are compassionate people. Okay? So it depends on what is the residues of that particular thing. So now, from now onwards, if someone asks you what are the poles of a system, you always say they are the characteristic modes of the system. They are the natural frequencies. No question of transfer function becoming infinity. What happened? Because transfer function doesn't exist. Transfer function doesn't exist. Clear? Any questions on this? Any questions on this? Okay. Characteristic here. These 2 points, you can just, I'm just putting it here. I will give you the annotated copy of this thing to Professor Veera Kumar. He will circulate you later on, what I'm writing here, right? Eigenvalues of the system are the characteristic modes. Poles of a system are the subset of its characteristic modes. So those things we will talk later. This slide, just read it here. The seed of a plant contains all the genetic information necessary of the development of the plant. It serves as the blueprint of the plant's structure, growth pattern, and eventual form. The inherent characteristics of a plant, such as its species, traits, and features, are encoded in the seed. Similarly, the dynamic behavior of a system is embedded in the characteristic modes. Don't say that, never ever say that transfer function, because transfer function doesn't exist, right? Right. Now let us go a little bit further. Everything is energy. We are all vibrating. It's clear? We have got characteristic modes. Any problem here? Resistance do not exist. Nothing exists. I am telling you from the very beginning. Nothing exists. Right? I think somewhere it is there. In every year, our final year students, they have got a dinner and they will vote who is the best teacher or something like that, and best quotations. So I have got many times, one year, one batch gave, nothing exists. A big certificate, I got it from the department. Nothing exists. Everything is a bloody illusion. Bloody term may be considered to be bad here, very common term. Nothing exists. Everything is a bloody illusion. The certificate is given to Dr. Swai. So I've got a good certificate. So nothing exists. Resistance do not exist. Inductance do not exist. Capacitance do not exist. Nothing exists, you see. Everything is energy. What is resistance? Resistance has the capability to model the phenomena of energy loss. Understand this point? Everything is energy. Either it can be energy loss or energy storage. Resistance has the capability to model which one? Phenomena of energy loss. Say, for example, a flat surface. The flat surface do not have the capability to store liquid. Right? What am I point? A bowl has got the capability to store liquid, right? So similarly, resistance has the capability which can model, which can represent the phenomena of energy loss. Similarly, inductance and capacitance, they have the capability to model the phenomena of energy storage. They can store, right? Inductance can store the energy in its magnetic field, and capacitance can store its energy in its electric field, right? See, I've written here. It models. See, everything is model. It never exists. Phenomena is phenomena. Okay? It's phenomena of energy. This is also model here. Model. Quickly we should go through that, then I'll... Static system. Static system do not have any memory. Resistance. You apply voltage, you get a current, right? Straight. Dynamic systems has got memory. Dynamic systems, always remember, dynamic systems, this point is important. Any system which has got energy storing element, which has got energy storing elements is a dynamic system. If there is no energy storing elements, it is not a dynamic. Resistive circuit, static system. Now see here. This is R, this is L. Dynamic. Is a dynamic system. How many inductance is there? One inductor. So this is a first order system. Dynamic system, order of the system. Now let us go to the second one. This is L1, L2, C1, C2. So this is a system. How many? This is a dynamic system or static system? Dynamic system. What is the order? Fourth order system. Okay? Because there are 4 energy storing elements. It's independent energy storing elements, but doesn't matter. There are 4 energy storing elements. So this is a fourth order system. Fourth order system. Okay? So this particular system can be represented, can be modeled by a fourth order differential equation. It has got 4 number of eigenvalues if it is modeled in state space. 4 characteristic modes, right? Everything is 4, right? You see, while I'm talking here, I'm very precisely using the words. I'm telling this circuit can be modeled by a fourth order differential equation, right? When I say can be modeled, circuit has nothing to do whether you model it or don't model it. It doesn't bother. If you need it, then you can model it. Got my point? Modeling phenomena does not require any model. You require. That point always in the back of the mind you should know. Therefore, the model is false. Okay. So, static system and dynamic system. The problem is with the dynamic system is stability is an issue. I will give a little bit example here. Stability is not an issue in static system. Stability is an issue with dynamic systems. Why is that? I'll tell you. I'll give an example, then things will be clear. The response for the dynamic system I'm talking about, response depends both on present input, if it is there, and memory, which is stored. I'll tell you like this. Static system. Suppose there is a student. He has written something in the answer script, right? If I am a static system, I will go and see his answer script and check whether he has given the correct answer, right? And accordingly I give the mark, right? Static system. Dynamic system. The same thing the student has written, but that student, yesterday while coming from the airport, that fellow, he misbehaved me. He talked something nonsense to me. Now, when I am checking his answer script, memory is there. Oh, this fellow, while coming yesterday from the airport, this fellow was talking nonsense. This answer is correct, but with precision, this is not correct. So instead of 10, I should give me 8. See, you got a point? Because my response is now depending on the memory also. Because I remember this fellow is a nonsense fellow. And this fellow, he gave me a good treat. Okay, he's not doing good, but doesn't matter. Let us give him who sees it. Give it some mark. Impression. Got a point? So this static system and dynamic system, if I've got memory, then the response is depending on your what has been done, what has been stored, right? The initial conditions in differential equation solutions, initial conditions are the amount of energy which has been stored in the energy storing component of the system. I always ask these questions to students. X dot is equal to Ax. What is Xt? This is the question. You see, this question you can ask the students. X dot is equal to Ax. What is Xt? Now, is there any input here? Now, if there is no input, how there will be response? This violates the principle of conservation of energy, right? There is no input, and how can there be response? Very common thing, right? We ask the students in the control class, X dot is equal to X, find out Xt. Then before they find out, I'll do wait. You tell me physically, there is no input, how can you get a response? The response of this system is because of the initial condition. And what is the physical meaning of initial condition? The energy which has been stored in the energy storing element of the system. So therefore, this x of t will be equal to e to the power at into x0. This x0 is the initial energy which is stored. If there is no energy stored, nothing will be there. Response will be 0, right? And whenever you will find dot, means there will be some energy storing element. There is some energy storing element, right? Any questions until now? See, these things I have explained here. RL circuit, concept of system order, everything which I discussed. Okay? You can go through the lecture handout, you can know it. Okay? Differential equation modeling, transfer function modeling, those things I am not going into that. Impulse response, very interesting thing. Impulse response, I always tell this, impulse response of a system, right? Why it is so important? Okay, why it is so important? Impulse response, why impulse response is important? Why not other response? This example I always give it to my students back in those countries where the people are from different countries are there. We have got one Upanishad that is called Mundak Upanishad. Whether you people are reading it or not, I am a voracious reader. Every day I read. Every day I read. And my wife and myself, we will always quarrel. Even this time when I come in Hyderabad airport, I bought 3 books. Gita for the children, Patanjali Yoga Sutra for the children, and there is some another book. I put it in hidden because my wife will get irritated. Why so many books? Okay. In Mundaka Upanishad, I tell to my students, I'm talking engineering, remember, it is getting recorded. The live streaming people sing here. I'm not talking nonsense now. In Mundaka Upanishad, the disciple went to the master. The master asked him, tell me, why you have come here? What you want to learn? See the answer. What is the answer of the student is telling? Understand the question? The student went to the teacher. The teacher is asking that why you have come here? What you want to learn? He is not telling I want to learn physics. He is not telling I want to learn chemistry. He is not telling I am to come here to teach mathematics or electrical engineering. He is telling, see the intelligent person, teach me that thing by knowing which I will know everything. teach me that particular thing, by knowing which I will know everything. That is the bloody impulse response in the current engineering context. If you know the impulse response of the system, the response of a system due to impulse input, then you can know the response of the system to any other inputs. Got my point? So therefore the impulse response is important. See how intelligently that fellow told it, right? Response, if you know the impulse response, then see these things I wrote it here. If we know the impulse response function of a system, that is the response of a system to an impulse input, the response of the system to any arbitrary input can be found by convolution. Right? No other input response. Right? So therefore it is very important. And the transfer function is the Laplace transform or Fourier transform of that. Okay? Impulse response function, you take the Fourier transform, you will get the transfer function. Transfer function don't exist. Okay? But if you know the transfer function model of the system, understand this point. If term is very important. If you know the transfer function model of the system, see the wordings. If we know the transfer function model of the system, then you can identify the poles just by looking into that. Otherwise, it has nothing to do with that. Otherwise, I can know the characteristic modes by some other means, right? So let us assume from now onwards that we know the transfer function model, right? Suppose the transfer function model of the system is k into s plus 1. Two examples I am giving. By s into s plus 2 into s plus 3 into s plus 4. Just an example, quickly we will do it. For this system, what is the order? What is the order? Order is equal to the total number of roots in the denominator. Okay? 1, 2, 3, 4, right? Fourth order system. Fourth order system. Right? What are the characteristic modes or the eigenvalues? Eigenvalues and the characteristic modes are same. Poles are little different, I will tell you now. Eigenvalues are 0, minus 2, minus 3 and minus 4. They are the eigenvalues, right? And zero concept I am not given, I will tell you later on today. First example. And what are the poles? The same as the eigenvalues. They are the same as the eigenvalues, right? Now, let us go to a second example. Then that will make the things clear. GS, the same system I am telling, k into s plus 1 by s into s plus 1 into s plus 2 into s plus 3. See, very carefully observe these things. These points are not emphasized in the textbooks. K into s plus 1 by s into s plus 1 into s plus 2 into s plus 3. What is the order of the system? Order is equal to 4. Order is equal to 4. Eigenvalues also 4. I am writing here. Eigenvalues are 0, minus 1, minus 2 and minus 3. What are the poles? The poles are 0, minus 2 and minus 3. There is a pole zero cancellation. Right? S plus 1 by S plus 1 got cancelled, right? So whatever you see in the output, those are the poles. What happened? Suppose I went to a family. The family has got 5 members. There are 5 members in the family, inside the family. So what are the eigenvalues? 5. Right? But when I ask questions, the father and the mother, they come forward. The children, they stay inside. So how many poles are there? 2 poles. Poles are those frequencies which are observed in the output. Okay? Eigenvalues are which are totally present. This example says that. Right? K into S plus 1, by S into S plus 1, there is a cancellation. Interesting thing. Okay, wait a minute, so I'll tell you the concept. Analogies are not perfectly correct, but you're going to get the concept here clearly. In a particular family, suppose your sister is married and she went to her in-laws house, and exactly the same time your brother also got married and your daughter-in-law came to the house. So the number of ladies in the house remains same, are the same. Got a point? There's a pole, there's a cancellation, but it's not the same. Things are different. Huh?
In that case, son or daughter.
Huh?
We are assuming that son or daughter, but daughter-in-law.
Yeah, that only, yes. It's different now.
And that's we cannot combine.
We cannot compare it, yes, that's right. So this pole cancellation is a very interesting thing. Pole cancellation, I'll give an example here, a nice example here. Many times, we in control engineering, so that you can understand this thing, system is internally unstable. See this point I am writing, internally unstable. This happens in many pole cancellation system. Externally stable. Externally stable. Internally unstable, but externally stable. Then I'll give an analogy, don't wait for that. Suppose K into S minus 1 by S plus 5 into S minus 1 into S plus 3. See this particular system is unstable. The minus 5 plus 1 minus 3, right? This system, the eigenvalues, you see eigenvalues are at minus 5 plus 1 and minus 3, right? This is internally unstable. Internally unstable, right? But if you cancel it, this one, this becomes K by S plus 5 into S plus 3. What are the poles? Poles are at minus 5 and minus 3. Externally stable. Got my point? Externally stable. Internally unstable, externally stable. How it is possible? Let's see, very common thing. Very common. You and your wife wants to go to, in the evening time, you want to go to some restaurant or something. Suddenly, because in Indian context, nobody would telephone to come to your house. Suddenly you find that you have got an old friend, 15 years back friend we have not met, he suddenly arrived. Or he called you that I am coming to your house for dinner. You are getting ready to go to some place, but suddenly there is a thing. Naturally, your wife will be irritated. But you told, no, you see, I've got a 15 years old friend. He's coming. So we must cancel our program. Your wife is seriously reacting. Okay. But your friend came. Then when your friend came, your wife will come. It will, in a very smiling face, it will, okay, yeah, yes, he was telling about you. Many times we talked about you. You have done a great job. Anyhow, you came here today. We are very happy to host a dinner. Internally unstable. That this bloody fellow, why he came here. Okay? But externally stable. Got a point? Externally he is not showing his many times. Suppose now you people, you may not like me. You are internally unstable, but externally you are laughing. Okay? What we can do? Professor Bira Kumar is there. You see, GIAN coordinator is there. They will feel bad. You got a point? So, these type of things are very serious things. We will talk about those things, hidden mode oscillations in nonlinear systems further. Understand these things? So, eigenvalues, characteristic modes, poles, clear? Nothing exists. All these things, transfer function, all these nonsense things, they don't exist at all. Okay, they are all models only. Right? Zeros. Zeros. What are the zeros of a system? Now, poles of a system are the singularities. If we apply an input whose frequency is equal to the poles, it will be, the response will be infinite. Right? So, for example, I will tell you like this. Suppose I will ask this gentleman, okay? See the questions I am asking. Question is the input frequency. Who are you? My name is these things. Where are you from? No, I am from these things. Are you teaching control? Yes, similar courses. How many children you have got? I have got 2 children. How many illicit relationship you have got? He will give me a slap. Pole. He is answering everything, but his secret he is not telling. Because he has got multiple mistresses, he is not telling. The moment I ask him, he is violently reacting. Got a point? That is one thing. Poles of the system, singularities, system violently react, resonate. Zeros. Zeros are where he remains silent. You apply, I will give you the example here. You apply an input, the system will not respond. System will give output 0. Okay? In America, they say it, 5th Amendment. In America, whenever the trial is going on, they will ask the police officer, can I exercise my 5th Amendment? That means, can I remain silent on certain questions? The judge will be asking some questions. He will say, I exercise my 5th Amendment. I will remain silent. 0. What is your name? You answer. What is your father's name? You answer. How much bank balance you have got? Not violently reacting. Violently reacting whenever I am telling that whether you have got some illicit relationship. That is pole. How much bank balance you have got? Silent. 0. So zeros are the frequencies where the response is 0. System will not respond. See here how, see here. These 2 circuits, just see here. We all know if I apply a DC signal, in the first circuit, there is a capacitance there, right? It will block it, right? It will block it, the output will be 0, right? Similarly, here, the output is 0. Now you see the S is equal to 0. S equal to 0 means DC signal. S equal to 0 means a DC signal. Zeros are the signal where it is blocked by the system. System will not respond. System will remain same. Okay. There are many other examples of 0. Here also this is system. Now see here, yes, S square plus 1. For the 0, plus minus J1, okay? Okay, so one thing if I don't know, if when I say that the signal of frequency is J10, when I say that the signal of frequency J10, what does it mean? What does it mean? I say I have got a signal of a frequency J10. What is the meaning of that? That means it is a sinusoid, either cosine or sine, doesn't matter, whose frequency is 10 radian per second. Radian, in control engineering we talk about radian. So here the 0 is at plus minus J1. When the 0 is at plus minus J1, that means if you apply a sine omega t, sine t or cosine t, doesn't matter the magnitude, the output will be 0. Right? Now suppose I have got a system which is s square plus 4 by something. So if to this system I apply sine 2t, output will be 0. Because what is the 0? What is the 0? Plus minus J2, right? 0 is at plus minus J2. What is plus minus J2? Either sine 2t or cosine 2t. You apply that signal, it will be 0. If anybody is teaching the circuit theory, you will go to Charles Deuger and Ernest Kuh book. That book is not in publishable format now. In the impedance function, there he has given a very complicated circuit and he has found out the 0. You will find that that particular frequency inside that circuit, one short circuit will occur. Make everything 0. Very nice example. When I was writing my book, I was taking that example. You will not find, in so many books I have read, you will not find those things. Okay? So, next lecture will be interpretation of zeros you see here. See this. Poles are the modes of the system, the characteristic modes of the system. Zeros of a system are the frequencies of the input for which there is no forced component of the output. Third point, if the transfer function model of the system is known, then the poles of the system are the roots of the denominator polynomial and the zeros are the roots of the numerator polynomial. The poles are the values of S, where the transfer function becomes infinity. If the transfer function is known, right? Otherwise, you have to find out some other way to find the poles. The order of a system is the number of independent energy storing elements in the system. Any questions here? Any questions? Is there anything else? No, that's fine. I think. So in this lecture, what I covered here is static system, dynamic system, nothing exists. Everything is energy. Okay? The poles, zeros, they are the characteristic modes of the system, right? And any other things I want to discuss? Any questions here? Then we'll have a break. We'll have breaks for 15 minutes. No? Otherwise, the people will be forced vibration will be too much. Yeah. So we'll close now, and then we'll see in the next lecture. Yeah. Huh? No, multiple poles. Good question, good question. If there are multiple poles, where it is coming from? Let's see. You are angry, okay, your brother is angry, you two people went to fight someone, so there's a S plus 1. Got a point? Cascading systems, two systems cascaded together, there it is S plus 1 whole square, or S plus A whole square comes. Okay, there are 5 members. The 5 members went to fight with another family. Okay, so 5 poles all are angry. Got a point? So, right. So we'll see. Next lecture. Any other questions? Yes. Yeah, guy, come forward. You come here. Don't wait for that.
System is like
Good question. His question is, when we say system is stable or system is unstable, right? Always remember, system will not allow any system to be unstable. We are not that fool. We are human beings. Okay? Will not allow internally unstable means, say the current will go, the speed is remaining constant, but inside the current will be very high. Will not allow that. When you say the system is unstable, okay, very good question he is asking. J is equal to K into S minus 1 by S minus 1 into S plus 3 into S plus 10. Right? Internally unstable. Right? When I say it is internally unstable, actually whether system is internally unstable? No. The transfer function is internally unstable. Always remember. All these definitions when we talk about, we give the model-based analysis we do. So the transfer function is internally unstable. Okay. System, because system has got some mechanism which will stop it. Instability normally we don't observe. Although we study instability extensively, we don't observe. So system never becomes internally unstable because we have got mechanism to stop it. If there is a current sensor and the current is exceeding certain value because of this reason, we will stop it. Even instability also, all the systems which are unstable, actually is not unstable. Who will tolerate instability? Who will tolerate? Because we have got mechanism to stop it. Always, all the systems have got mechanism to stop it. This is for your understanding. Okay? So that's the point. Otherwise, the internally unstable, externally stable, what is the meaning of that? The very nice joke it has come before. The fuse, which is there to protect the transistor, became so compassionate that the transistor which is being protected by the fuse, became so compassionate that ET itself blows up and protected the fuse. So fuse is protected, transistor blows up, right? So we'll close it and we'll see in next lecture about what is order is 3. Order is always 3. No, yes. Pole order of the system, to do it, don't cancel any pole 0. Okay. This thing has been discussed only in the old generation of the Ogata book. No other books have done it. So don't cancel the pole 0 while calculating the. That's the eigenvalues. Eigenvalues are these things. So essentially the characteristic modes, actually we don't say characteristic mode, it's actually natural frequencies. But these mechanical people, they use the natural frequencies in their job. So therefore to respect those mechanical people, we say this is characteristic modes. Otherwise it's essentially natural frequencies. And this energy concept, so those things we will talk offline. Energy concept, when Swami Vivekananda came, there is a French actress, so Sarah Burnett, so she organized a meeting with the, who is that fellow, Serbian fellow, Tesla, Nikola Tesla in Belgrade, and Swami Vivekananda told him that stop doing all this research, do everything is energy. But Nikola Tesla went to America and he did something with the Westinghouse, with the Edison, on the transformer development, all these things. He did not do that. Einstein did it. So it is all come from the, and it has come in the GIAN. I think it is not in this slide. In the GIAN, what Nikola Tesla is telling, that I met an Indian saint and he is telling that everything is pranic energy and which is true. It is all common in the GIAN. Okay, we'll see. How much time break is there? Yeah. Yes. Well, we should, rather we will extend a little bit to 1:10, but we should take 10 minutes because these people will. Recording stop? That's good. So that we can talk anything, nonsense. Yeah? Is that okay? This entire cosmos, what you see, if you model us, these are called the singularities. Another concept I'm giving, then I will relate everything here. Singularities. You understand the meaning of singularity of a function? How many of you, the academic staff, are teaching control course? Just raise the hand. Just we are friends. Yeah. Right. So what we did in the last lecture that we gave some concepts, basic concepts, very basic concepts. Initial control theory, when it came up, it was all based on the transfer function model of the system. Okay? Most of the things in control theory, not only control theory, signal processing, also engineering and science, are model-based design, control design, model-based analysis. What is the meaning of that? The meaning is, first you find out the model, then you use that particular model to do the analysis and subsequent design. Clear? Model-based. There is a model-based design. Another is model-free design. Model-free. But most of the control of designs as well as analysis are model-based. Okay? The classical controller, when you talk about classical controller, okay, they are based on the transfer function model of the system. When the term classical controller comes in picture, classical controller, that is based on the transfer function model of the system. Always remember, I am again emphasizing, which I will continuously emphasize in this course, that models do not exist. It is a mathematical abstraction, right? The phenomena exists. Don't miss that. If you miss it, then everything is lost. Your understanding is lost. Now, suppose we will see tomorrow how to model by transfer function. That we'll see. Suppose the transfer function model is given, then how to analyze the system, model-based analysis, classical analysis, and how to design a controller. Classical controller design is based on the transfer function model of the system. 1960s, a new model came up in MIT, state variable model. The state variable model that gave a name, different name, not classical control, it came the modern control. Modern control, when I say modern control, it has nothing to do with modern as we say today, right? Modern control is those control techniques which are based on the state space model of a system. Got my point? Modern control has nothing to do with the modernity. It is based on the state variable model. It is based on the state variable model of this system. What is state variable model? Let us understand these things, then before we proceed. This is the point. This slide, let's see. A system having n number of independent energy storing elements can be modeled. See the wordings I am using here, be careful. Can be modeled, I am not telling is model. Modeling is your choice. You may model it, you may not model it, right? A system having n number of independent energy storing elements can be modeled by a single nth order differential equation. So what the state variable model does, it does not use a single nth order differential equation, it splits it. The state variable model essentially represents the nth order system by n number of first order differential equations. What I point? The single nth order differential equation is now represented by n number of first order differential equations. Okay? So therefore, thus a single nth order differential equation here becomes n number of first order differential equations. Right? Now why it is that? Then it becomes easier to solve and do the analysis. Because all the equations are first order. Right? Just one example to give you, because suppose here mx double dot plus fx dot plus kx is equal to u. So if I define one x1 is equal to x and x2 is equal to x dot, then the first equation will be x1 dot will be equal to x2, right? And x2 dot, I am not entering into that because that is equal to x double dot. If you take it to other side, you will find this is the case. And this system is now represented by x dot is equal to ax plus bu and y is equal to cx. So instead of a single higher differential equation, you can split it into only first order differential equations, right? I assume that you know state space model, right? And all the analysis and the controller design which is made by this state space model is called the modern control. X dot is equal to x plus bu and y is equal to cx plus du, right? One is dynamic equation, another is algebraic equation. Y is equal to cx plus du is the algebra. Anyhow, this is the point. I will take a little more time. I will tell you, if we will answer this question, our understanding about control engineering will be around 70% clear. Only simple this question. Is it necessary to use a controller, to design a controller? People say, we have to design a controller, right? Is it necessary? Is it a mathematical gymnastics that we will design a controller? Okay? When we are doing PhD in England, in the postgraduate office, there is a news some 2-3 pages writings every week comes. Why should you do PhD? Once it has come up. When I was doing PhD in 1994, one thing is, if you will do a PhD, people will think that you are intelligent, although you are a bloody idiot. You are an idiot. You have no brain. But you are doing PhD. You know what is the meaning of PhD? You know it. I'm telling you, it is recorded. That's fine. The people listening to live streaming, they will know it. That these are the foreign faculties telling these things. One day, one fellow from Fiji National University was talking to me and he told me, who will do PhD? Those people who has passed high school with difficulties. PhD. Only those people will try to do PhD. And then, once they get enrolled into PhD, then this screw will become little bit loose. There will be partial head damage. PhD becomes, from past high school difficulties, it becomes partial head damage. And after completion of the PhD, that partial becomes permanent. Got a point? So this is what the PhD means. Understand these things? Okay. So one thing which came up, that if you want to do PhD, people think that you are very intelligent. So similarly, the question is it necessary to design a controller? Okay? If we understand these things clearly, you will find, you will see today's lecture, your understanding about the control engineering will be 70% clear. Let us see. We'll see. Those things are writing, forget that. This analogy which I am giving, suppose you have got a child, teenage child, and he enters into, we said grammar school means higher secondary schools. Class 9, 10, 11, grammar school, okay? Higher secondary school. Now suppose, today, your child enters into a grammar school, higher secondary school. The question is, will you employ a tutor from today? You tell me. Let us answer it very carefully. You understand the question first? You have got a son or daughter, and she got or he got admitted into the school today. Will you employ a tutor to come to your house and teach your child? Certainly not. You are not that fool. Clear? You are not that fool, because once a tutor is coming to your house, you have to pay money. What a point? You are not that fool. Now, see here, consider the example of a student studying in grammar. Grammar school means the higher secondary school. Assume that the student has opted the following courses: physics, chemistry, mathematics, and English. Now, what you will do? You will not employ a tutor. You will wait till the first term examination, school examination is over. Right? First term, school test. After 2 months, there will be a school test. Suppose he has taken these 4 subjects. Now assume that this is the percentage. He has got physics 90%, chemistry 85%, mathematics 95%, English 70%. Will you engage a private tutor? No, because they almost desired performance. Wait till the first test and study the open. Wait till the first class test, that is, study the open loop performance of the system. Study the performance of the system without the controller. That is the open loop performance of the system, right? Student performance without private tutor. You first do it. That is the. Now let us see, interesting things are coming up. Now suppose after the first test, this is the performance. See. Open loop performance of the students, suppose the marks of the students got without a tutor. Tutor is the controller, we'll see. After the first test are as follows. Physics 87%, chemistry 78%, mathematics 94%, English 10%. What you will do? There is no other way out. You have to employ a private tutor. Yes or no? You have to employ a tutor. Controller is a must, right? Then again the problem comes. So I need a tutor. Otherwise, you will not get your dinner at home. Your wife will beat you. What the hell you are doing? Your child is scoring 10% and you are thinking that he will become a Shakespeare. Right? Now 10% in English. Horrible performance. There is no other way out. Then what I should do? I have to employ a private tutor, right? Should I go to the outside this NIT campus and stand on the road and hold my hand? My son has got 10% in English. Will anybody interested to come and teach my son? Should I do that? If I do like this, then many people are driving, they will stop there. Okay, I am unemployed, I will come to your house. Because they will get money. Yes or no? Should I do it? Should I go to the Panjim railway station and ask? So many people are coming out of the train. My son is doing 10% English. Anybody is coming? Should I do that? Should I do it? So I must employ what? An appropriate tutor. Appropriate, not any controller. We'll come to that point. Not any, there are many types of controllers. I have to employ an appropriate tutor. Who is the appropriate tutor here? Either an English graduate, or if I am in academics, I will go to the English department, okay, Faculty of Humanities, I will talk to the English HOD, I will say that, you see, do you have any PhD students who are interested to teach? So he will say that, okay, I have a couple of PhD students, I will ask them. So you get an appropriate tutor, right? Those people who have got knowledge of what? English, right? That is called the appropriate controller. We'll come to that point shortly. Employ an appropriate tutor. In this case, an English graduate at least, minimum English graduate, right? Now let us see. You studied the open loop performance. You found the open loop performance is significantly below the desired performance. So you have to employ a tutor. You have to employ an appropriate tutor. And you got the appropriate tutor. The tutor is coming to your house. He is teaching to your child. Everything is fine, right? Now the next question is, very interesting question. Second test comes. First test is the performance. By second test, there is a tutor coming to your house, teaching there, right? Suppose we engage an appropriate tutor to teach the student. Are we sure that the performance of the student will improve in the next test? That is the important point. Can you guarantee? Can you guarantee that the performance of the student, your child, will improve? Everything is perfect now. Tutor is perfect. Very nice person. English graduate. Even English gold medalist coming to teach. I will tell you, this is the universal truth. What is the universal truth? There are some universal truth. Universal gate, NAND gate, NOR gate. Correct me, Professor Vida Kumar, I have no knowledge on the electronics now. NAND gate, NOR gate, right? Universal truth. There is another universal truth. All the married people knew it. Two people in the entire cosmos, if there is multiple universe according to string theory, that is truth. Two people in the entire cosmos, they always think that you are not useless, you are bloody useless. Who are they? One is your wife, another is your child. Your wife will say, what you are teaching to the students? They are listening to you. Huh? You cannot explain me how to run this Excel spreadsheet. I am asking you. You cannot put the towel in the proper place. How organized you are. And my son, who is also an engineer, electrician engineer, he said, Baba knows nothing. Yeah. You cannot switch on the television, cannot tune it properly. Huh? Sometimes when I was teaching him, he knows, okay, Baba knows little bit of mathematics. Otherwise, he knows nothing. Huh? And he will tell to my PhD students, your luck is very bad. Huh? You are doing PhD with my Baba, my dad. Huh? My student says, Dr. Swami, son is always son. He will never understand you, right? So they will think. Now, your son does not listen to you. Your son doesn't listen to your wife. How do you guarantee that your child will listen to that tutor? Performance is bad in English. You employed appropriate tutor. But if the child does not listen to the tutor, no matter what he teaches, performance will be bad, yes or no? What is technically it means? The system is uncontrollable. The system is not listening. System is uncontrollable. Then, gone, right? I am coming to this uncontrollable. You see, suppose the student does not listen, obey, carry out any advice of the tutor, the system is uncontrollable. Then no matter how good the tutor is, the performance will not improve. Clear? So don't design the controller because you are intelligent. It is not intellectual gymnastics. There are so many steps. Okay? More complications are coming, just wait. System is uncontrollable. So before employing the private tutor, the controller check whether the student is willing to listen to the tutor. That is, test the controllability property of the system. And if the system is controllable, then employ appropriate tutor. Right? These things has not been mentioned in many of the textbooks. Controllability. What is the meaning of controllability? Let us understand very clearly. I will tell this boy or the gentleman, please bring me a cup of tea, and he obeys my command. Then he is controllable. Please do this job, and he does it, he is controllable. Right? Take me to Panji to see the sightseeing. He is going with me, he is controllable. Right? And if I ask him, please bring me a cup of coffee, suppose he said, am I your servant? Why the hell I should go? Uncontrollable. Yes or no? Then I will say he is uncontrollable, right? That is not a correct thing. That is not correct thing. So whether he is controllable or he is uncontrollable, controllability is not the intrinsic property of the system itself. Now, I will ask him, please go, let us go to the Goa to see a movie, and he is not obeying with me. He is not obeying my command. Uncontrollable. But his girlfriend is coming and telling, let us go today, away to the beach. Oh, look at that. How come it's possible? The same person, when I tell him to go to the beach, he is telling that I will not go. But his girlfriend is telling that let's go. He is going, yes or no? So how can you say he is not controllable? So controllability depends not only on the system, but the person who is telling the input matrix. The system has x dot is equal to x plus bu. A is the system matrix, that is the property of the system. B is the input matrix. Who is telling it? So the controllability, if you see the mathematically, the controllability of the system, I am showing mathematics, then I will B, AB, A square B. You see? These things. You should have full rank. So the B matrix, who is telling? Who is telling? Right? My son, I always say, he will not take some of the dishes my wife makes. But I've got a friend, his wife, she is very strict. He'll tell, you have to take these things. There is no other way out. System is uncontrollable at home, controllable there, that place. Got a point? Input matrix, who is telling? Okay? Suppose you don't, if your colleague says something to do, you will not do it. But a director says, you will do it. So controllability is not an intrinsic property of the system itself. It depends on the input matrix. What is the meaning? That means if the system is not controllable, you change the signal which is coming, you know. There's no different places you place the sensors, you get different signals to make the system controllable. Right? So before designing a controller, is it visible? Okay. This is from my book, I have put it here. I'm just doing it line by line, sorry. Start. Define desired specifications. Study the open loop performance. Open loop performance is equal to desired performance? Yes. Stop. No need for controller. If it is no, perform controllability test. Controllable? Yes. Design appropriate controller. No. Make the system controllable by modifying the input matrix and then do it. Right? So these are the steps. Okay? And these things, this procedure has to be followed no matter which type of controller you are designing. Right? But one thing I must tell you, you must be very careful. Controller is an outside element. Understand the analogy? Analogy is not clear. Controller is an outside element. He is coming to your house. He is entering into your house. Remember, state variable, you are entering into the house, not transfer function that you are standing outside the house. Transfer function is the outside external description. State space model is an internal description. Transfer function we will discuss tomorrow while talking about modeling. Because now you know you are entering into the house, you know everything in the house. Right? Now suppose that tutor is a young fellow, I am not telling because this is recorded for the offline, something happens in the house because you have got other members also. So instead of improving it, it will deteriorate the performance, it will make the system unstable. Got my point? So you must be very careful while employing a controller, right? So, but controllability test is a must. But while doing the controllability test, be careful, it is not a property of the system. If it is not controllable, change the input matrix, right? Design the control. This is the standard thing, testing controllability. System is controllable if it's possible to move the state from any initial state to any final state. So those things are there. I assume that none of you are teaching control course. How many of you actually you are not, have you studied control course before? While you are student, right? When you become staff, then you say that the control people are useless people, will not teach or will not write. No, that's understood. There is no need of telling it. Now I'll make very interesting things, I'll make it here. No, not that I'll make interesting things, I'll make those things which may be interesting for you. This is controller. You will get used to it, my handwriting by tomorrow. This is the system. And this is output Y, this is Y reference. Plus, minus. This is the error, and this is the command signal. We said command signal, EUC, going to the system. Understand very carefully. Okay? These type of control systems are called the output feedback control systems. What are called? Output feedback control systems, because the output is feedback to the input. You compare it, error is there, then the output of the controller is the command signal, right? If in future you will study control engineering, you ask the students like this. Y reference is equal to Y. This is the error, right? You want this error should be 0, yes or no? Then now the moment the error becomes 0, the error is going to the controller, so the UC becomes 0, then the output becomes 0. You got a point? Just think of these things. It is a confusing thing, actually. No book has given this type of concept. Your reference, you understand the question first. You are comparing, you want the error should be 0, and the output should be equal to reference. But the error becomes 0 means the output will be 0. So what is that? I'm just giving that so many words to explain it. Remember here, I'm just giving a diagram here. This is the error, and this is UC. UC is here, you see here. This point, right? One case. Some constant. You see, with the error is 0, the error may be 0, but the command signal is not 0. See here, the one diagram I'm showing here. Okay, so that command signal is not 0. Always remember. If the command signal will become 0, then everything will be 0, right? Anyhow, so this is the output feedback control system. Classical control, the control design is essentially output feedback. You take the output and feedback, get the error, design the controller, that's it. In the state variable model, you are entering into the system and you know each variable of the system, right? So we use all the state variables as the feedback. So this is state variable model. So the control signal UC is equal to say minus of some gain K1 into X1 plus K2 into X2 plus K3 into X3. You see like this, state feedback. Okay? If you are teaching control theory, I will tell you one thing. Only one mathematics, one or two mathematics, you can know it. I tell always the students 3-4 mathematical tricks. Okay? The first thing, just to show their interest. This is what I do it in the class. In the first control course. 3 plus 4 is equal to 6. The question is, correct this. Wait, I think not coming. No, it is frozen, I think so. Yeah. 3 plus 4 is equal to 6. Correct it. Can anybody correct it? Tell me. Yeah. Not equal to 6. Okay, one. Anything else? One answer is 3 plus 4 is not equal to 6. That's fine. Okay. Any other answer? 3 plus 3 is equal to 6. That is all correct. Okay. How many answers are there? How many answers? Infinite. Okay, I did not put any restriction, right? I did not put any restriction. If I put a restriction without changing any numbers in the left-hand side of the expression, without changing the mathematical symbol, you correct it, then you will change the 6 to 7. Clear? So if a problem has got 10 number of possible solutions, putting 9 restrictions, 9 constants, you will get a unique solution, right? Theorem says that. That's one thing. Then another important point is, if this point is coming by the other side, I think. X dot, if x dot is equal to ax, then xt is equal to e to the power at into x0. Okay? X dot is equal to ax means xt is equal to e to the power at into x0. What is the time constant of this mode? The time constant, only these things, if the students understand it, time constant is equal to 1 by a. This is e to the power at means time constant is 1 by a. Right? 1 by a, that's the only this much would they have to understand, 1 by a. So if a system has got a pole at minus 10, then xt will be equal to e to the power minus 10t into x0. Okay? What is the time constant? What is the time constant here? Lambda 1? 1 by 10, that is equal to 0.1, right? Now, suppose minus 100, what is xt? E to the power minus 100t. What is the time constant? 0.01, right? There is a term called engineering infinity. What is it called? Engineering infinity. This e to the power minus at, this will go to 0 when time t turns to infinity? Yes or no? What is the meaning of that? Who has seen infinity? Who has seen infinity? Nobody has seen. What is engineering infinity? 5 time constants. By 5 time constants, 5t, that is called infinity. 4 time constant also infinity. By that 5 time constant, this system, second order system, 98% of its final value. So for all practical purposes, 5 time constants is the infinity, right? Now, this is fast or this one is fast? Which one is fast? 100 is fast, right? So if the poles are away from the j omega axis, why I am telling this thing, I will tell you. Poles are away from the j omega axis, this system becomes fast. Closer to the j omega axis, system is slow. Right? Clear? Now, I want, there is a powerful controller. So now we know location of the poles decides whether system will be faster or system will be slower. Suppose this is the j omega axis. If you are closer to this place, your response is slow. If you are away from that, response is faster. Right? The state feedback controller is not output feedback controller. Remember, it's not output feedback. If the system is controllable, it is possible to place the poles anywhere in the S-plane by suitable selection of the GIAN matrix. You will do it today in a tutorial by giving the MATLAB command, place command. Say, for example, I want you should be very fast. So what I will do? I will ask you to go outside the room and to go to the road. Okay, that is far from this place. You will be fast. If I want the system to be slow, then I will tell that you come closer to this place. Right? The j omega axis. If the poles are here, closer to the GMO axis, response becomes slow. Away from the GMO axis, response is faster. So, if the controller can do it, it can place the poles anywhere. Suppose the controller will place anywhere, system becomes faster, right? All the outputs cannot be states. Yeah, I understand. The X and I, it all depends. Now, his question is valid question. Suppose I have got a third order system, and it has got 3 number of outputs. 3 outputs and 3 states. So in that case, state feedback and output feedback are the same. What happened? So usually the state feedback means more number of states. Usually the number of states are more, usually. Otherwise, if the number of outputs are similar to number of states, then state feedback and output feedback are the same. Okay. Or even, no. Even for a fast order system, if that is the output feedback and state feedback, that's the same. No, state can measure that thing will come up, I'm coming to that point. But in general, the only what I'm emphasizing here is, I'll tell you interesting things. The theory says if the system is controllable, step number 1, then it is possible to place the eigenvalues anywhere in the state space by state feedback, not by output feedback. Let's assume the output and the number of states are more than the outputs. When this theory came, 1970s, there are some journal papers. What they do, they published papers and they will say, we are designing state feedback controller, placing the poles anywhere by output feedback. The theory does not support that. They will show the response. People have not understood this is not the control theorist. It is going to the other journal. What I mean? So output feedback, it is not possible. It is happening, that's fine. But output feedback alone cannot do it. State feedback cannot do it. Okay. The only problem is state feedback controller is very powerful controller. Okay. As Professor Amal told, we are coming to that states has to be observed. We will come to that point. The problem is, I gave a very generic statement. If the poles are away from the geometric axis, system is faster. Closer to the geometric axis, system is slower. Right? But what do you want? Where actually you have to place the poles? We don't know it. So that is the difficult part. First difficulty. And second difficulty is, the states are not measurable always. One difficulty, another difficulty is, the states are not measurable always. All the states are not measurable. There are some states may be measurable. I'm writing all the states. I'm not writing are measurable, I'm just may not be measurable. All the states may not be measurable. You cannot measure them. Then what you will do? You are designing a controller, U is equal to, say K1, I am not writing -1, K1 x1, K2 x2 plus K3 x3. Now suppose x1, x2, x3, out of which 2 states you cannot measure. Then you can do it. What I point? Because after all, you have to measure it, then multiply by certain things, right? So what you will do? If system is not measurable, the state feedback controller is powerful controller. State feedback controller is no doubt a powerful controller. It can place the eigenvalues anywhere in the state space, right? But it assumes that all the states are measurable. Now, if the states are not measurable, then we have to estimate the states. So, we have to estimate the states by using observer. We have to estimate the states using observer. So, in that case, this u will be equal to, see the expressions here, k1 x1 cap plus k2 x2 cap plus k3 x3 cap. Cap means estimated value, because you cannot observe. Huh? Huh? Yeah, if some are measurable, don't estimate it. If some are measurable, suppose x1 is measurable, you estimate those things. That's called the reduced order observer. Okay. So, pole placement controller is a powerful controller. That controller can only be designed if the system is controllable, but it has its own problem. Where to place the poles? First thing. Now, suppose you are an expert and you know where to place the poles, that's fine. But the states must be accessible. If the states are not measurable, you have to estimate it. And who will estimate it? Observer. Observer is a formula, it is an algorithm, it is an equation. It is not a device. Observer is not a device, it is a formula. Okay? Use that particular formula and estimate it and replace it here. Okay? Now, common sense. Suppose the open loop system poles are here. I want to place the pole in the back bench. Case number 1. I want to place the poles outside the building. Where the control effort will be more? Outside. Got a point? So, it's very common sense. So, again I am modifying the theorem now. If the system is controllable, then it is possible to place the eigenvalues anywhere in the state space by the use of an unconstrained control signal. There is no constraint on the control signal. If there is a constraint on the control signal, that the control output should be this much, then it is not possible, right? Okay. Yes. Constant. Otherwise, how can you place it, right? Now, see in this example here, the eigenvalues are placed at minus 1 plus 3j, and you see the control effort is 1. The eigenvalues are placed in minus 5 plus 3j, the control effort is 18. Okay? What a point? Another important thing I will tell you, because in many places throughout the world you will find people are working on power system. We will talk about those things when we will talk about Lyapunov stability later on. See the interesting thing. Some of the statements which I will make here, it may appear controversial, which is not. There is a nonlinear system. You understand this point? There is a nonlinear system. How the power system works, and most of the engineering system work. There is a nonlinear system. We will see all those things in nonlinear analysis. You get the equilibrium point. You get a linear model which is valid if the system is operating within the equilibrium point, in a small region around the equilibrium point. Then you use that model. That model is valid if the system is operating within the small region about the equilibrium point. Use that model to design a controller. Then in the simulation result, you see the journal articles. Simulation result, sudden short circuit in the transmission line. This is the response. I asked in the PhD oral examination of many people in the, what the hell you are doing here? Your model is a linearized model. The basic assumption is it is operating within a very small region around the operating point. You are designing a controller and you are showing the performance of the controller by a sudden short circuit, a large signal disturbance. When the large signal disturbance, the system operating point shifts to any place. So the linear model is no longer valid. The entire mathematics collapses there. Entire theory based on which you are doing the design is collapses. Okay? I always tell to those students, you dump this particular report in the Pacific Ocean. Go. I tell them, you go to Queen State and first dump it. It has no value. Fundamental assumption is around the operating point and the large signal disturbance. How? How is possible? Then they will say there is an argument you see. They will say, no, we put the large signal disturbance. This is our result. You cannot say the result is wrong. You cannot say the result is wrong. That is also true. The question is, what is the answer? Answer is, I am a sober child. I am a sober child. I always obey my parents. I behave perfectly. Whether you are coming to my house, it doesn't matter. You are coming to my house, I am sober. You live in my house, I am also sober. Your presence in the house doesn't matter me. The power system in general is always stable. It behaves nicely. You are designing controller because to get it published in the journal. Power system doesn't require it. It is almost stable. We have got around 12 students PhD, 12, 15 students PhD. One student is working on multi-agent control, power system. MPC-based sliding mode control. I told you, what the hell you are doing, man? Deep learning based. One of my PhD students from Indonesia, Gunawan Dewanto. Gunawan is doing on the deep learning based controller. I told Gunawan, one day Gunawan and myself, we laughed. I told Gunawan, you know and I know. This is all nonsense. Because why the hell I require a deep learning network? Deep learning network is required by Professor Veera Kumar working on image processing underwater acoustics. They require deep learning, a convolution neural network to enter to you. Right? So you understand what the meaning of deep learning? Deep learning means suppose he is sitting there, I will look to his face, then I will do some operation, I will see what is in the skin, then I will see what is in the bone, all the nonsense, the deep learning. Go deep. Power system, why I need a deep learning? But we are doing it because to publish a paper. And we are doing it while publishing papers. That is truth. That is the truth. This is recorded. People should know these things. We are telling this to people, you want to understand, deep learning, a simple PID controller can do the job. What is the necessity of using a very complex controller? Huh? Is it necessary? The entire power system is completely stable. Power system is completely stable. There is no point. There might be a little bit of stability issue because of the penetration of the renewable energy nowadays. Okay? But why to do that? Deep learning, machine learning, neural network, all these things will also cover. Reinforcement learning. Everybody is doing it. It's necessary. A simple PI controller can do the job. Simple optimal controller can do the job. Right? So you are attending this course also. I am telling, MPC when it came up, model predictive control, I tell you, the Manfred Murari who did it in 1990, that is essential for chemical plants, which is slow. I will also teach you one, not tomorrow, day after tomorrow, something self-tuning controller. When it came up, the Carl Ostrom did it in Sweden, then the David Clark. When I was doing PhD, David Clark comes to our university to examine master's thesis. I have seen that guy. And Peter Gothrop, one of his students, he was editor in journal, International Journal of Control, he comes to the university. Our department is control department. Many people come. Those are the people who have developed these generalized predictive controllers. GPC, you can go to Google, you can search it. Steve asked, "Hey, David, why are you doing this GPC? Do you think that it is useful?" Steve, don't ask those sort of questions. It certainly came to our mind and we just did it. Right? So, things are different. What you are studying here, machine learning, neural network, which you will do it in this course, that's fine, absolutely fine, no doubt about that. But you must know when a simple PI controller can do the job. Why to do this? Okay, just, so anyhow, so any questions until now? State feedback controller can do it anything, anywhere in the state space by constant control signal. If the states are not measurable, then you design an observer. How much time is there? 5-10 minutes? Or 5 minutes, I will close it. Okay. Oh, no, sorry. Please. Wait. Why is not coming? Yeah. Major problems of state feedback control design. You should estimate the states. You cannot estimate the states for all type of things. Suppose I will cover everything. I am talking here, I will cover everything. Observer means from the output, you can observe what is the states. I am giving an analogy, things will be clear. You go to the particular person house, okay? Your system is not, you see, you are not allowed to go inside the house, right? Suppose you have got a son, you are looking for a girl for his marriage, right? Then you go and tap the calling bell. The person will come, you ask him. You are not telling your intention. Oh, where are you from? No, I am from this place. What are you doing here? I am doing these things. Is your wife is at home? Yes, yes, he's there. Then she will call his wife. Then some discussion, then you find that the gentleman and his wife, they look handsome and beautiful. Then you came back, then you tell your wife, okay, I will go with the formal proposal. So your wife will ask, did you see the girl? No, no, I did not see the girl. See the point. I did not see the girl because they did not allow me. But from the look of the father and the mother, I could estimate that the daughter must be beautiful. Observe her. From the output, I can observe what might be the state. You got my point? Estimation. Okay, not measurement. Measurement is different. Estimation, I am estimating. Now, if the system is observable, then you can estimate the step. Now, suppose the father and mother, they came with full cover. They are talking to you, but you cannot see them. Then you cannot estimate. So, to estimate the state, the system must be observable. Right? System must be observable. Estimate the states. Oh, all these mathematics are there. There are different types of controllers, we will see. Many things we can discuss offline, but I will tell you something here before I close it within 5 minutes. The most important controller is called the PID controller. I will just tell you a little bit. Proportional controller, derivative controller, integral controller. It works on how much is the error. P controller, how much is error. This controller works how the error is changing. I will give an analogy, then things will be clear. Just a minute. How long the error persists? Are you getting to my handwriting now? After 1 hour? How long the error persists? Now suppose that is your son. Suppose he is in the mathematics out of 90, he is scoring 30. So there is a large gap. Large gap in the error. How much is, so proportional controller will work. You have to change the proportional gain. So instead of 1 hour mathematics, he should study 3 hours, 4 hours, right? How the error is changing. One test, he is scoring 90. Another test, he is changing 10. Another test, he is scoring 80. Another test, he is changing 50. So you see, it is changing. There is no consistency. So they are the, right? Derivative control will take care of. So if the error is changing, it will work. How long the error is persisting? Now, your child performance is bad. Whether it is bad in this, he is an eternal idiot or a temporary idiot. That means from the class 1, he is scoring 5, class 2 also 5, 6, 7. So he has been performance in this, what is that? In mathematics is always less. How long this particular behavior is there in integral controller? Is it recorded now? Okay, you can stop the recording a little bit also, otherwise it doesn't matter. My wife is not going to see. Now see here, I give this example so that you can remember it. Don't take, ladies, don't take otherwise. Otherwise they will say woman influence, all these things. No. The behavior of a wife is just like an integral controller. They will remember everything. 30 years back what you have done. Integral controller. It depends, integrate everything, you see. Integral from 0 to infinity. You are doing well now. No. 20 years back my brother has come. During that time you did not take him to the market. He came last year, I gave him so many gifts. No. You know, remember that thing? We have gone to that place. You don't remember that. These things you did, integral controller. Integral controller is exactly similar to your wife. He remembers everything and act accordingly. What I point? So proportional controller, derivative controller, and integral controller. Every house has got an integral controller always. Okay? And you will see, although integral controller has got this bad quality, but it is very useful. That is the only controller which can correct you, it can correct the steady state error. Because of the ladies, the house runs smoothly. So integral controller is useless when you are talking in the social sense, but actually it's very useful. Ladies are useful, otherwise the house imbalance will be there. Right? Everything. That is clear? I'll close the lecture now and we'll see. Any questions? Do you understand anything from the control a little bit? Even if you don't understand, you tell that you understood. So that GIAN people will know that you have understood it. Because they are watching us in the live streaming. Okay? See you then. And we'll see in the, tutorial a little bit.